So our first presentation is going to be from Carrie Sager. She is going to be talking about fireworks and their effects on brown bats.
All right. Thank you, Hannah. So good morning. It's great to be in the press room today. Actually, it's afternoon. I'm sorry. Those were my notes from presenting it this morning. Excited to be speaking about a project that Greg Cotton, the co-author this talk, led last year to add acoustical monitoring into the toolbox he usually uses when monitoring animals at the Capitola fireworks for trying to aid the city of Capitola, California, in better understanding what sorts of effects fireworks shows actually have on coastal wildlife. So the city of Capitola has a history of hiring ecologists and biologists to study the effects that their events can have on the ecosystems in their backyard. So Greg has been conducting surveys for them for a few years. What he typically does is for beach patrol surveys, someone will walk the beach the day before the fireworks to document which animals have already perished. And then after the show, they retrace their steps to determine if any additional animals are hurt or perished, meaning that would be an indication that something with the fireworks could have been the culprit for that injury or fatality. Also during the fireworks show, Greg does thermal image camera surveys, so that monitors the behavior of the animals that are out on the water. Since the animal bodies are warm and the water is relatively colder, you get to see cute little otters like this in the kelp forest and can determine if they swim away during the fireworks booms or continue to hang out. So usually otters, whales, seals are in these kelp forests around the pier. And they will usually suddenly swim away after the booms if they're close enough. Maybe they'll go below the surface once the fireworks start. Those would be evidences of disruptions caused by the noises. In this past year, we were able to add an acoustical aspect to the study. We weren't sure exactly what animals we were going to hear by putting out a passive acoustic recorder, but it turns out bats are the ones that we heard, and the big brown bat specifically. The calls that we heard are the ones that indicate feeding activity. So today I'll walk quickly through what we learned from those feeding calls of the big brown bats at the That's alliterative. At the Capitola Pier during a fireworks show. So just to orient all of us to a little ecology on big brown bats, they're native to a good portion of the contiguous United States. They have easily recognizable echolocation calls, like you can see in the black and white spectrogram there. They eat insects, mainly flying ones like beetles and moths. They're designated as least concern on the IUCN endangered species list, so they're not particularly worrisome in becoming endangered anytime soon, but what that means is they're plentiful, meaning they're easy to study. So any time that they react to disturbances like fireworks, it could tell us something about other bat species that eat in this way, how they may be disturbed, and those may be endangered ones that we care more about for conservation purposes. So disturbance types that are particularly important to bats, therefore, are the noisy ones, because most bats, including the big brown bat, we need a nickname for these guys. These bats usually use echolocation to find food, meaning they have to be able to hear that echoes off of their food, like the reflection, to say, oh, the food's this close in front of my face, or this close, so that they can home in on it. And then something like the fireworks then would prevent them from finding those food because it would mask or cover up the echoes. So that could be a conservation issue that needs tackling if the noise from the fireworks is getting in the way of their feeding. So particularly interesting to our case study is that this happened in October when Capitola has their annual fireworks display. And that's when big brown bats are in their breeding season and they're about to enter winter hibernation. So think little flying bears. They are probably very interested in packing on the calories at the time. So they're going to want all the snacks that they can get. That means their feeding successes will likely determine their hibernation and their reproductive successes. So there's 3 phases here. We've got the searching echolocation calls. And then as they get faster, we have the approaching phase for the echolocation calls. They're getting closer to their snack. And finally, these terminal calls, these very fast ones. So if you think they have to be able to hear the echo that comes back before they emit their next call, and as they get closer, that distance gets closer and closer. So they've got to click faster and faster so they can hear that echo and really home in well. So this acceleration or this buzz at the very end, that is what I wrote very simple rules for. If we see that, they got a snack. If we didn't, they didn't. So we're just counting how many snacks they made and how many times they tried to secure snacks. So we did a BACI, a before-after, during control impact study, starting with the during, because that's the loud fun part, right? You can see all this red down here. These are the fireworks. During the fireworks show, you can see the bats in the little blips, light blue blips halfway up. So the bats are still around. They are still searching for food. They searched for about 13 calls per minute, but had no snacks. Comparatively, what we think they should have been doing during this time would be represented by the half hour before, where they had 91 searching calls and 2 per minute, and then 2 snacks per minute. So for half an hour now, they've lost potentially 60 morsels of delicious moth. After, the question then is, do they rebound? How well do they rebound? Not at all. They do rebound a little bit. Over that next half hour, they got up to 44 searching calls per minute and a snack about every 3 minutes. So not all the way up to where they were before, but there is some rebounding, and that seems pretty quickly for within half an hour. So you can see half the amount of time spent searching after versus before, 81% less feeding after versus before, no feeding during, and 85% less searching during the fireworks compared to before them. So I found this one recovery piece very interesting. I'm going to show you the one super sciencey plot at this time. So each one of these little bins is a minute. It's how many search calls or blue were happening and how many snacks were had or pink. We had this really weird, you see this little blip of fireworks at the end. Not all the shells went off. And you can hear the guys on the radio go, oh no, we have some that didn't go off. Could we shoot them off now? Because otherwise they're a hazard, I guess, if they just don't actually let them explode. So they went ahead and had a second false finale. The during numbers, like those searching calls, during the main fireworks show, there was only a handful of them. It was actually in this little recovery time before the false finale, where they were starting to recover again, feeding is where those during calls came from. And they had a really good effort at searching right when the finale started again. And then stopped again for a second, and 5 minutes later came up. So you had this quick searching peak right about 5 minutes after. That got interrupted again. And then 26 minutes after, we had the most searching effort of the entire night. So the question that this brought up, as I was talking to Greg, he goes, well, don't moths get attracted to light, and fireworks are light. If the moths are around, or the bats staying around to eat the moths, because now so many moths have been attracted into the area. And my answer is maybe. The question would be like, do they stick around because they're plentiful anyway? Like the moths are coming in, they're plentiful, they're going to put up with the noise because snacks are more important. Or maybe the fireworks aren't actually attracting the moths and pulling the bats in. It could just be less energetically costly to move to a different place where the bats don't actually know if there's moths or not, so they may as well stick around in this place where they know that they are. That would be a question for future research, and I can also take questions from anyone else.
I'll start. Questions in the room?
Thanks so much, Carrie. Yeah, we can start with questions in the room while we wait for questions from the live stream.
Hi, so I have a couple of questions. I guess first to start, you mentioned that that this sort of time period in like late October where these fireworks are happening is sort of the breeding season for these bats, and they're preparing for hibernation. I was wondering if you had any plans, either with you and Greg or someone else, to look at sort of quantifying the long-term impacts on the bat populations that are from these fireworks.
Yeah, long term, I'm not actually sure what the city of Capitola wants to do. This was done very much for them to try to be good stewards of, their city and their property. That, I would almost defer that to Greg, who is online. If they were interested, we would do it. We would have to probably do more density estimation studies in the roosting areas for bats to see if they're more concentrated away from louder parts of the city. And in being Capitola, there might be Highway 1 might be louder than one fireworks show a year. I think that might be pretty difficult to tease out. Not saying that we couldn't do it or that there's not an interest in doing it, but yeah, I hadn't really thought of it.
I gotcha. And then can I ask my other question? Or?
Sure, go ahead.
Okay. I guess my other question is, you mentioned like sea otters and whales. I was wondering if you could talk a bit about some of the other animals at that area, in the area that you studied, that are also affected by these fireworks.
Yeah, I didn't put the super physics slide in here because I wasn't going to do math to people on a Tuesday afternoon. In the thermal scope that Greg was taking the survey for, he did note there was a humpback whale out in the kelp forest. There were sea otters, like I'd shown that image out there. I think there were some sea lions around, cormorants. The pigeons flew closer to the fireworks because I guess they're pigeons. The radius around where that sound spreads and propagates out in the environment, we did a little bit back of the envelope math of how far out from the fireworks on the end of the pier would a behavioral disturbance level be reached. And that was 232 meters from the pier. All the animals that Greg was measuring on the thermal imaging camera were over 300 meters away. So there weren't any marine mammals actually in that disturbance zone. So they kind of like sunk, like they weren't really around during the show, but then they were there again. So the humpback whale could have held its breath that long. It could have just hung out underwater, right? And the otters could have like hid under the kelp and then popped back up. They don't seem to have been particularly disturbed. They were within visual sight, but they were not within like that hearing range of a disturbance level.
Right, thank you.
I think we had some questions up here. Yeah.
Yeah, I apologize if you covered it already, but I was wondering if you could speak a little bit about how you filtered out the fireworks noise and you only got the bat's like echolocation sound.
I didn't have to. It's like delightful acoustic niche partitioning all by itself. Where's my spectrogram? There we go. I clearly can use PowerPoint. I want to walk over there. Here. So like this, like that yellow and red, that's just waves crashing on the beach and like some kids talking about how cool the fireworks show was. So like those little red lines are human voices. And then the bats being all up in the blue, you can sort of see how even the fireworks, when it's way louder in our hearing range, are not as loud up in the bats one. What would be masked and covered up would be like those vertical streaks at the explosion itself. I was a little afraid I may not have caught. There might be a couple of bat pulses I did not catch. There were not many. Those are pretty thin vertical lines, and you can kind of tell by the beat. The beat. Even as it accelerates, I wasn't really missing much in there. That was lucky. I would not want to filter out fireworks noise.
All right, thank you.
All right, and we have a question from the live stream. What do you think causes the delay between the end of the fireworks and bats resuming their hunting behavior?
My reaction was it wasn't that long of a delay. I was pretty impressed within 5 minutes that they were back at it. I learned today, actually, so I usually do whales, FYI, not bats. I learned from a bat person today that big brown bats are one of the species that is least disturbed by noise and has the least amount of age-related hearing loss. So I'm kind of wondering if this species just genuinely didn't care about the noise. So they were able to kind of hop back in and at least try searching again. The other question that we didn't answer in this was I do have data from days before and after where I could look at the natural trend through the night, and it is possible that they're just winding down snacks by that time anyway. So to really say that they rebounded, I would need to compare it to their activity at the same time from the nights before and after and be like, oh, they went back up to what's normal. It's not always necessarily that they're going to be going back to what was an hour before if they have a general nightly trend. Yeah, questions to be answered later if I look at more data.
That's really good stuff, though. It's things we need to know. Thank you, Carrie.
Yep.